Contact TR1A closes. DCV1 Sol A is energized. DCV1 shifts to the straight-through position. Pressurized flow enters the cap end and the cylinder extends. At the limits of extension, the mold strikes limit switch LS1. The LS1 contact opens and de-energizes the controlling input of timer relay TR1 and the coil of control relay CR1. Contact CR1A immediately opens and removes the holding circuit. In contrast, normally open time-open contact TR1A executing the off delay function remains closed and the timer begins the 30-second countdown. While the countdown is ongoing, note DCV1 Sol A remains energized. The valve therefore remains shifted into the straight-through position and the cylinder remains extended. The pressure-compensated pump reaches the firing pressure and destrokes to the high-pressure standby state. The mold is being compressed with the requisite amount of force and remains so while the timer executes the required 30-second countdown. After 30 seconds has elapsed, the normally open time-open contact TR1A opens, which de-energizes DCV1 Sol A. The spring offset DCV1 returns to the cross-connect position. Pressurized flow enters the rod end and the cylinder retracts. Upon reaching the reset region of LS1, LS1 resets into the closed position. When the cylinder fully retracts, we again return to the de-energized start state of the system. As previously, the stop button would de-energize DCV1 Sol A, depower and reset the timer, even during an ongoing off-delay period, and return the system to the de-energized start state. Note how by subtly altering our ladder logic, principally the deactivated state and location of the limit switch within the ladder logic diagram, and making use of a totally opposite timer function, we successfully created a system that performed the same single-cycle reciprocation action, incorporating a 30-second dwell period. Here's yet another implementation of a single-cycle reciprocation system incorporating a dwell period, only this time making use of a positive edge-triggered one-shot. Let's assume the cylinder needs to again fully extend and maintain compression for a period of 30 seconds. Note this simple ladder logic does not require a limit switch. Recall that the limit switch in the two previous examples was the prime feedback mechanism used to notify the system it had reached the limits of extension and the system needs to initiate the required dwell period. This particular system does not include this level of feedback, and for this reason the positive edge-triggered one-shot's delay must be modified to account for the travel time to the limits of extension as well as the desired dwell period of 30 seconds. Let's say the travel time to reach full extension is a repeatable 5 seconds. The timer executing the positive edge-triggered one-shot is therefore set to execute a 5 plus 30 or 35-second positive edge-triggered one-shot upon receipt of a positive or rising edge at the timer controlling input. Let's assume this is a non-retriggerable one-shot. It may be helpful to review the behavior of a positive edge-triggered one-shot before we continue. This particular timer executing the positive edge-triggered one-shot function necessitates an additional auxiliary controlling input illustrated as a coil with 3 terminals. The coil from A1 to A2 must be continually energized for the timer to properly function. The auxiliary controlling input now serves as the initiation signal for the one-shot function, whereas the coil simply serves to power the device. A timing diagram of a timer necessitating an auxiliary controlling input executing the positive edge-triggered one-shot function would look like this. Assuming the timer is powered up using the A1 to A2 connections, when the auxiliary controlling input receives a positive or rising edge, the associated contacts temporarily assume the opposite activated state. After the one-shot period is elapsed, the associated contacts return to their deactivated states. Being non-retriggerable, this timer would simply ignore additional positive edge triggering events experienced within an ongoing one-shot. Note the de-energized start state of this system ensures that the internal circuitry of the timer relay is powered up. As previously, an operator initiates the single-cycle reciprocation incorporating a dwell period by pressing start. The controlling input of timer relay TR1 experiences a positive or rising edge. The positive edge-triggered one-shot is headed downrange, and an operator can release the start button without the necessity of a holding contact. Contact TR1A closes and energizes DCV1 Sol A. DCV1 shifts to the straight-through position. Pressurized flow enters the cap end and the cylinder and mold extend. 5 seconds into the ongoing 35-second positive edge-triggered one-shot, the cylinder and mold reach the limits of extension. Contact TR1A remains closed for an additional 30 seconds, maintaining the energized state of DCB1 Sol A. The valve remains shifted into the straight-through position, and the cylinder remains extended. The pressure-compensated pump reaches the firing pressure and destrokes to the high-pressure standby state. The mold is being compressed with the requisite amount of force and remains so while the timer executes the remaining 30-second countdown. After a full 35 seconds has elapsed, contact Tier 1A opens, which de-energizes DCV1 Sol A. The spring offset DCV1 returns to the cross-connect position. Pressurized flow enters the rod end and the cylinder retracts. When the cylinder fully retracts, we've again returned to the de-energized start state of this system. As previously, the stop button would de-energize DCV1 Sol A and depower and reset the timer, even during an ongoing one-shot. An operator could use the stop button to cancel an ongoing reciprocation action and return the system to the de-energized start state. Note how by subtly altering our ladder logic, principally ditching the limit switch altogether and making use of a totally different timer function, we still successfully created a system that performed the same single-cycle reciprocation action, incorporating a necessary dwell period. This being said, there is a notable weakness in this system as currently implemented. Yes, the ladder logic is substantially simpler, and it does save money on limit switches, but it does necessarily rely on repeatable extension times that may or may not be a reality. Additionally, this system never actually checks to see if the mold has reached the limits of extension, as did our previous examples. This could be a total deal breaker if the cylinder ever jammed mid-stroke. In that case, the one-shot would still keep DCV1 in the straight-through position for 35 seconds, regardless if it was doing anything useful or not. This being said, for a simple system with a predictable extension speed, the simpler ladder logic making use of a positive edge triggered one-shot without a limit switch might still be a workable, inexpensive option. Alright, that is it. In conclusion, this lecture took a brief look at several different implementations of electrically controlled hydraulic systems that executed the single-cycle reciprocation action incorporating a dwell period. We examined systems that made use of on-delay timers, off-delay timers, and positive edge-triggered one-shot timers. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest. We'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.